Hello, this week we're going to introduce the for loop.
Things we're going to cover is what's a control structure, what is a loop. We'll look specifically at a type of loop called the for loop and discuss the type of variable you need for a for loop, which is called a counter variable, and we'll step through an example.
Think about how would you write a program where you need to process payroll for 1,200 employees. Pretty much the code for employee 1 is the same as the code for employee 100. I want you to pause the video for a second and think about how you would write that program. Okay, so I was thinking maybe you can just, let's say it takes 14 lines of code. It's going to take way more than 14 lines of code to process one employee. You could copy and paste those 14 lines 1,200 times. Probably don't want to do that. Let's see. You could just write the logic just for one employee and then require the payroll clerk to run it 1,200 times. It probably won't work either. You could write one method. You could write one method, put the 14 lines of code there, but then I'd have to call the method 1,200 times in main. That's a lot. So that's what this video will be addressing. Let's first talk about the concept of control structure. So the author defines a control structure on page 93 as a syntactic structure that controls other statements. Not very much to that. Another definition would be it's a statement that will indicate what statement you're supposed to go to next. You don't necessarily go in order. Two Italian computer scientists, Bohm and Jacopini, in the 60s, they had this insight. You can write any program using only 3 ways to get to other statements. And the first way is sequence. That's what we've been doing. You just go right in order. Statement 1, statement 2, blah, blah, blah. The second is selection. You might have heard of, if it's this, do that, else do that. We do this in everyday life. You can also do it in programming code. And the third is repetition. And this is what we need for our 1,200 employees. We need to repeat the code. We don't need to copy and paste the code or call a method 1,200 times. We need a loop that will repeat the code. Other statements that we may have are a halt and also a procedure definition, which we're calling a method. So we've already done methods, and really you want to include methods in a good program, a well-structured program, even though it's not one of the basic 3. So let's take a look at why this is a big deal. In the 50s and 60s, we have in this example here some assembly language, and literally it got to be known as spaghetti code because these arrows are showing, see, JMP means jump. These arrows are showing the logic in the order that these statements were executing. The problem was, how do you maintain that code if you can't even figure out what's going to happen next? Structured programming was introduced, and that is much easier to maintain. And here's an example. With structured programming, as we mentioned, we're not going to be jumping around like spaghetti code. We will use statements that are in sequence or within a decision or within an iteration. Sequence, here's a flowchart for it. And a flowchart is a way to just show your algorithm, just like pseudocode shows your algorithm. So flowchart sequence, you just do one after the other. With a decision, also called a selection, also known as an if statement, right? You have a choice that's going to be true or false. I'll tell you, when I used to live by the Mississippi River Bridge there, 74, and before they replaced it, it used to get backed up. So I had to make a decision. I would go out and look, and if I saw cars backed up on the bridge, okay, if that were true, if that was true, that's what that T stands for, I would go this way. And this way means maybe I would run over to the Centennial Bridge, right? Or if that was false, hey, going to take the 74 bridge. In the end, this is, in a way, we can call this branching. You're going to branch that way or you're going to branch that way. In the end, I get to the same destination. Okay, so in coding too, regardless of what branch you take, you get to the same destination and you continue. With this third type is a loop, and this is where you're going to repeat. As long as something's true, we're going to repeat those statements. Now the flowchart just shows one box, but this could be many, many statements. It could be 14 statements, and you're going to repeat it until you got 1,200 of them done, let's say. And then when that condition is true, the condition that you finished 1,200, false, and then you go ahead and go on with the rest of your code. So what is a loop or a repetition or iteration? In this comic here, I don't know if you know Jason Fox, smart kid, got in trouble. He threw a paper airplane in class. So the teacher says, I want you to write that on the board 500 times. I will not throw paper airplanes in class. They used to do that. Yeah, smart kid, he actually used a language called C++, and he used a for loop. He created an integer variable called count, and he counted 500 times and wrote that down. Unfortunately, the teacher's not going to take it. I would have taken it. I would have thought, clever Jason, I'll take that. Yeah, if he didn't have a for loop in Java, you'd have to have 500 of these statements. Let's take a look at what it's going to look like in Java compared to C++. So we have a for loop. It's pretty simple. That's going to do 500 times. Let's talk more about for loops. So here's the syntax. Like a method, a for loop has a header, the top line, and the body, which is in between a pair of braces. You can have one statement. You can have many statements inside the for loop. Once you go into the loop, every statement will execute. So the header has the for, and then in parentheses, you'll have a section that initializes a variable, tests that variable, and updates that variable. More on that on the next slide. The body can be anything you want to repeat. So here's the header. Again, here are the three sections in the header. These are not arguments, though they look similar to the method header. They're not arguments. What you're doing is you're creating the loop so that it is going to set up to exit correctly. So the first part, initialization, happens only once, right when the loop begins. You're going to initialize that variable. The second part of this loop tests that variable to see if you're going to go on the true part or the false part. The true means, yeah, I want to do the loop statements. The false means you're done looping, go on. And then the update's going to modify that loop control variable, and you need to do that, or you might have the dreaded infinite loop. Well, what's an infinite loop? An infinite loop means that your program never exits the loop. So you see how important that update is. If you never exit the loop, then your user's just going to see a spinning world that'll never go, that'll never stop. You almost have to Control-Alt-Delete out of there. How it works. Here is an example of repeating 500 times. We're initializing a variable. I'm calling the variable I. Notice the int here. So we're declaring and we're assigning the value of 1 right here in the for header. Then there's a semicolon. Here's the test. Well, as long as I is less than or equal to 500, and then the first time through the loop, I is 1, so that's a true condition. And then here's the update. Remember last week, I++ means add 1. Okay, so as we're going through the loop, first time, let's say it's first time through the loop. Oh, I'm going to have a variable I. It's going to be 1. That's true, and it doesn't do this yet. First time through the loop, it does the first 2 items. Well, that's true, so it will print out, I will not throw, blah, blah. Okay, it loops back up. Now, every other time but the first time, it comes over here to the I++, and it does it. So 1 becomes 2, and then it comes over here and tests. Is 2 less than 500? Yeah, so it goes in and does it. Oh, third time through the loop. Okay, this is not the first time, so we'll come over here, and 2 becomes 3. It tests. Okay, etc. Finally, you get up to, say, 499, and we loop back up, and that becomes 500. Is 500 less than or equal to 500? Yes. So it loops again, and we come back up. 501, false, we're out of here. So it does that 500 times. I did want to note that the author calls these definite loops. I've never really seen that a lot. So they're more commonly known as counter-controlled loops. Because what are we doing? We're counting to 500. I is a counter variable. There is a definite number of times that the loop executes. There are other types of loops. It's not always known ahead of time how many times you want to execute. So we'll talk about those types of loops in a few weeks. All counter-controlled loops require a counter-control variable or a loop counter. It's initially, you start it as 0 or 1. It normally is initialized to 0 or 1, but it doesn't have to be. If you want to initialize it 100, that's fine. As long as you know what you're doing and you're making the program do what it needs to do. And the increments usually add by 1, right? I++. And then the loop condition, which is this part here, is the test. It determines true or false whether you want to remain in the loop. So 3 parts here. Another type of loop we'll cover in a few weeks is the while loop. And notice that each of these things that you need to do with the loop counter is done on different statements. So that's why the for loop is so great. All 3 are done right here in the parentheses in the for header. Did you know that a counter variable in a for loop is often called I or J or K? Doesn't have to be. You're going to have a discussion to find out what's the history behind that. I normally call it I, J, or K. Also, another thing is usually you're going to declare it to be an int. Normally you count by integers, 1, 2, 3, 4, 5. You don't very often count 1, 1.11, 1.115 like that, which would be a double. So declare it as an int. And normally we're counting up, but you don't have to. Sorry about this. This is minus. PowerPoint put it together as a long dash, but you can decrement. So you can start at 10 and count down to 0. Or if you want to count by 2s, remember these operators from last week? So this will take I and add 2 to it every time it goes to the update. Or this one will subtract 10. So normally it's this one, but it can be other ways to do it. Here's an example. Before the loop, I'm outputting column headings. Don't put the output for column headings in the loop, or column headings will output 10 times. Do you see that? So the column headings are output for the loop. Notice the /t escape sequence. That's putting 2 tabs here for me. Then I'm in the loop. I'm going to call this loop control variable number, which is fine. Assign it 1. And I'm going to test, is 1 less than 10? Yeah, it is. So then we're going to print the number. Well, it's 1. Then we're going to print 3 tabs. And then we're going to print number times number. Well, 1 times 1 is 1. So what this is going to do is loop 10 times, printing the number, and then printing the number squared. That's pretty, I hope you understand that. That's a pretty simple loop to understand. A few things you don't want to do in a for loop is an I here. I is declared here. And notice, since that's fine, you can declare your variable outside of your for header. And notice int I is not here because it's declared up there. And this looks okay, but I++ is incrementing I here, and then we turn around and increment I here. Normally, you're not going to change your loop control variable in a for loop in the loop itself. So here's the output, because I's getting add to 2 times. Let's look at this one. Oh, this is about scope, and we've got a video on scope coming up. Just be aware that if you declare your counter variable in the for header, you can't access it outside the for header. So if you want to be able to access your counter variable outside the for loop, then you need to declare it outside the for header. Okay, so that finishes up this video. Read through the material and you'll be ready for the quiz.